Contains duplicate. What if I told you that something as simple as checking for duplicates trips up more candidates than you'd expect, especially when speed and efficiency matter? Contains duplicate is a Pattern Mastery 100 classic, and it's a screening favorite at companies like Amazon and Apple. More than 50% of applicants try to brute force it. If you can nail this one, you're showing interviewers that you know your data structures and can think in real time. Let's see how pros do it. Let's break down the problem. You're given an array of integers, and you need to determine if any value appears at least twice. If any number shows up more than once, return true. Otherwise, return false. Super simple, but it tests your ability to spot the most efficient solution. Now let's assess our options. A brute force approach would check every pair, (n² time, but that's slow for big arrays. Instead, can we use a set to keep track of what we've seen as we scan the list? Sets in Python have O1 lookup time, so this lets us check for duplicates instantly as we go. This gives us an efficient ON time and ON space solution. Here's the structure of our plan. Create an empty set to store numbers we've seen. Loop through each number in the array. If the number is already in the set, return true, we found a duplicate. Otherwise, add the number to the set. If we finish the loop with no duplicates, return false.
Let us try to implement it using Solution 1. We begin by defining our solution class. This is the container that holds the method we are about to explain. Then we declare the method contains duplicate. It receives an integer array and must determine whether any value appears more than once. Next, we sort the array using Java's built-in sorting method. Once the numbers are sorted, any duplicates will sit right next to each other, making them easy to detect. This sorting step takes O of n log n time. After that, we loop through the sorted list starting at index 1. We begin at 1 because we will always compare each number to the one right before it. Inside the loop, we check whether the current number matches the previous number. If they are the same, we have found a duplicate, so we return true immediately. And if we finish the entire loop without finding any adjacent duplicates, we return false because all numbers are unique. And that is how this algorithm works. It first sorts the array so duplicates become neighbors. Then it checks each pair of adjacent elements to see whether any are equal. Efficient. Simple. Clear. Check. This test verifies the duplicate detection logic. Input. Nums equals 1, 2, 3, 1. The goal is to determine whether any number appears more than once. Walking through the array, 1 is seen for the first time. 2 is new. 3 is new. The next one is already in our scene set. Because the second one repeats a previously encountered value, the algorithm correctly returns true. The output is true, matching the expected true. The solution properly detects the presence of a duplicate. Let us try to implement it using Solution 2. We begin by defining the solution class. This simply holds the method we are about to walk through. Then we declare the contains duplicate method. It receives an array of integers and must determine whether any number appears more than once. Next, we create a hash set called S. A set automatically rejects duplicates, and checking or inserting into it takes constant time on average. This is what makes the approach optimal. After that, we loop through every number n in the array, one by one. Since we make only a single pass, this loop runs in O of n time. Inside the loop, we try to add the number to the set. Here is the clever part. If the number was not already in the set, add returns true and the loop continues. If the number was already in the set, add returns false, meaning we have found a duplicate. So we immediately return true. And once the loop finishes, if we never encountered a duplicate, we return false. That means all numbers were unique. Final summary. And that is how this algorithm works. It sets up a hash set to track scene values, scans the array once, and lets the set reveal duplicates instantly. Efficient. Simple. Clear. Check. This test confirms the logic when no duplicates exist. Input. Nums equals 1, 2, 3, 4. The algorithm scans each value and tracks what it has already seen. 1 is new. 2 is new. 3 is new. 4 is new. No value appears more than once, so the algorithm correctly concludes that there is no duplicate. The returned result is false. The output is false, matching the expected false. The solution behaves correctly for an all-unique input.
Let's have a quick recap. Breakdown recap. This problem challenges you to identify if any number in a list appears more than once. It's simple on the surface, but it tests how quickly you can detect repetition using the right data structure. The goal is to confirm duplicates efficiently, without comparing every single pair. Assess recap. We started by evaluating two main strategies. The brute force method checks all pairs, but that quickly becomes too slow for large inputs. The optimized approach leverages a set, a data structure designed for instant lookups, allowing us to check whether a number has already been seen as we move through the array. Structure recap. Our logic followed a clear flow. Create an empty set, loop through each number, and check if it's already inside. If we find a match, we immediately know there's a duplicate. If not, we add the number and continue scanning until the end. This structure keeps the solution both logical and efficient. Implement recap. In practice, we simply track numbers in real time while looping. Each step represented a quick check and store operation. Constant time, no wasted effort. By focusing on the idea of seen versus unseen, the program effectively mirrored how our brain would remember past values in a sequence. Check recap. When tested with a sample array, the logic worked exactly as expected. As soon as a number appeared for the second time, the function identified it instantly and returned true. This confirmed the one-pass efficiency and correctness of the approach. The key takeaway here is that the simplest problems often reveal the most about your coding instincts. Choosing the right data structure, in this case, a set, transforms a slow, clunky solution into a clean, scalable one. It's a perfect demonstration of how thinking efficiently makes you stand out in technical interviews.